So I haven't been on in a while. I've been busy, but I thought I'd come on this Saturday and just do a sort of like a live shop tour. I've got a lot of projects I'm going to work on out here, so I'm just going to go over them. It's not going to be edited. There's no bullet points. It's just me talking. With that being said, there's a couple things in the back of my mind I wanted to talk about. So let's start out with information. Where do you go to get information for control line precision and aerobatics? And there's other organizations. There's multiple RC special interest groups, and there's also multiple special interest groups for control line. But the one I'm familiar with is PAMPA. So I'm encouraging you to think about joining PAMPA for this reason. And the biggest reason I can think of is it's a great time because you've got all the information that was presented. Oh, I don't know, we'll go through it on the computer, but since PAMPA was first published, I believe, when Paul and Keith Trossel and maybe another person started PAMPA. But the beauty of today is you can go back and access all that information on PDF files for 40 bucks. And that's a year membership. So, okay, so what's $40 get you, okay? Back in the day, there was, computer just turned, back in the day, I mean, you can still get this. This is a Stunt News. This is 2017 and 96 pages, okay? And there's stuff in there, contest reports, different things. But there's also how-to articles in these PAMPA magazines. So for $40, you have access to every PAMPA issue that was printed. So being a member, I decided to opt out of the printed version and just get the PDF file sent to my email. And this is the latest Stunt News right here. I took it to the printer and just had them print off a copy. Now you can do it at your home printer for pennies cheaper. You can just do it all in black and white. But I had it printed off at, you can go to Kinko's, a UPS store, Staples. They can do a nice glossy heavy paper print for you, or you can do it at home. I know Keith Trossel, I've seen him with his binders, so he'll take articles that are specific to certain building technique and he'll categorize them in a binder. So if you get this downloaded as a PDF and you don't want to print everything, you can just pick and choose and print these articles out that pertain to what you want to know. So this is the updated version, the quarterly issue, number 4 of 2025. And as you can see, I mean, it's all color, beautifully laid out, edited issue. So I encourage you to do that. Now, PAMPA, PAMPACL.org is the website. And let me flip this camera around. I'm doing this live on a cell phone. And let me get the computer screen. I'm not savvy enough to go in here to do a screen swap or anything. So I'll show you what I'm talking about, how to navigate. Okay, this is my computer screen. I'll go down there, explore my browser. Let's see, I'll put in pampacl.org. It's already got me remembered. Okay, so you pull up this PAMPA site and it's available to anybody, anytime. And if you're a membership, or if you're a member, you can join, or if you're not, you can go to the memberships and join. Since I'm a member, let's log in. So I'll click on login. It's got my email. It's got all of my information stored. So now I'm on the member page since I'm a paid member. So up here at the header bar, you're going to see more choices than you had before. Let's click on Stunt News, and then you got members directory. I'm not going to share that online. If you're a member, you can contact other members through this, but let's go to Stunt News. And to me, this is the magic right here. 2024, 2025 is out, so they'll probably update that. Right down here at the bottom, 1970 to 79, those are all the old issues. Okay, so it goes all the way up here to 2024. And if you click on 2017, let's just say that's what you had the year, and you're going to see the issue that I just showed you in paper that was sent to me. So let's give that a double click, and it just showed right here that it downloaded that file, and it downloaded it as a PDF file. Now you can download that PDF file to your phone or your laptop or whatever. Let's open the file, and lo and behold, here we are at 2025 with this issue here. Okay, it's all at your fingertips through this collection of PDF files. And you scroll down here, and here's the complete PAMPA newsletter right here in front of you. So, membership application form, I'm not sure if that's still pertinent, but you can get on a newer issue or go through the website to join. They'll take your money online. I know these people, Tom, he's still doing it with the plan service and stuff. So you're going to find access to some suppliers that advertise in PAMPA. And you go through here just like you'd see a printed version. So to me, that's invaluable. Let's click the back button here if we can get back. Let's see, maybe close that out. We'll go back to pampaseal.org. Log in again. Somehow I got out of it. Stunt News. So let's go to, let's say 1980 to 1989 down here. Let's click on this and see what comes up. That was the year I graduated in high school. So, wow, 1980, 81, 82. There's a lot of years here. So let's just pick one, 1981. See what comes up. So this is what Stunt News looked like before computers. I think when Paul, editor, he sat down at a typewriter and actually typed each newsletter out, copied them and sent them out. Now there's still some really good articles on construction in some of these issues that are still pertinent. So there's my advertisement for PAMPA. You know, it's a valuable resource to gain access to all these articles. Do one more here, 2016. Now, 2016 they used the same thumbnail for the cover. They didn't do individual covers. But you're going to have different content behind each one of these thumbnails that are the same. Looks like Casminato got lucky. He was the thumbnail. And we're going to go over here. We're going to open the file. And here we are, 2016. Looks like, see Orestes, see articles, there's Big Art, John Brodak, President's Report, all in perfect color. There's Paul and Dave, they're still active. So yeah, if you download these files on your phone and you're sitting waiting to get into the dentist or something, and you're sitting there, you can read any PAMPA issue you want. There's Joe Daly. I was out of the hobby for quite a few years during work and all the goings on. There's Will. He looks a lot younger there. Let's see here. Yep. There's some great photography too. Here's Mike Palco in blazing color. And here's some shop tips. And here's another note. Robin's View Production Foam Wing Services. He still gets on the Hangout and does short tutorials covering foam wing stuff. Sparky on Stunt Hanger, he's actually put up a lot of Bob's videos that Bob gave him, so you can revisit Stunt Hanger to watch some of these older videos. So yeah, $40 will get you every back issue up to 2024. So that's what I wanted to cover real quick. You know, you don't have to have stacks and piles of all this stuff. You can just get them as PDF files, print them out. So what I'm going to do here, I'm going to go through this shop. I'm just going to ad lib. I've got to do some control horns today. I've got a bunch of deflashing of some carbon parts. Here's a wheel pan. I got half started. Excuse me, half started. Almost fell off the stool. So this plug, I think I did a short video on this plug. I made a parting board, and I'm in the process of editing it. But this parting board was a little bit different than the Formica. So this is half the mold. You can see these little clay bumps here I put right here. Those actually allow the second mold to key into these little bumps. What's going to happen on this mold is once I make the second half of the mold, I got to trim off all this glass out here. I'm going to make a cutout at the bottom. So let me see if I can catch these comments real quick. Yeah, I'm alive, Steve. So, yeah, here's the, I'll show you real quick. That's where your wing's sitting. But it's ready to be sheeted. I'm not at that point quite yet. Now, the reason why I was MIA is, I'll get back to this in a second. In the past, I do work for JT Composites, and they're up on Gasoline Alley, and they're super great to work for. What I do for them, I'd go in there and make workbenches and anything out of wood. And they presented me with another woodworking opportunity I couldn't pass up, and I decided to take it. So I come home after the first day of work, and it's like, yeah, I got to get back in the groove here. I mean, I'd come home from work and pretty much vegetate and go to bed, but yeah, it's a it's a fun job. It's a great job. But what had happened, it was a combination of a lot of things. Um, yeah, we got a foot of snow, and we're buried in snow here, and I was supposed to get some stuff sent out to people. And then my neighbor that had quadruple bypass surgery. Um, yeah, I'm fine. I guess I sort of go into hiding, but what I did is shovel snow for 2 days, and after that, and then I started working. So I got behind, needless to say. But let me take you over here and show you a couple things after this mold. But anyway, I'll make the second half, and this mold will be cut out at the bottom. Okay, so when the mold comes together with these parts already laid up with glass, I'll put the mold halves together, and then I'll be able to go down through the center of the opening and actually seam it. And that way I can join the two halves together outside of the mold, or inside the mold, I mean. Here's another project I was working on, and I made some samples, and Bob's got one of them. It's a carbon fiber bell crank, and to get the shape, I form it on these it's on this aluminum plate. Once you form the whole sheet, then you pull it off, and you've got this sort of like a corrugated roof looking thing. When it comes off the sheet, it looks like this, okay? And then you cut the bell cranks out of it, and then when you flip it and you glue these two pieces together, that's how you get the fork in the bell crank. So the way it's situated now, this is just the prototype. Obviously I've made what you see here, okay? In the next week it's going into work, and they're going to pre-preg carbon on this plate. And pre-preg is a different animal than wet lay. It's basically commercial grade process with high modulus carbon. The idea is to get this a little bit thinner and still as much strength. This is set up for probably, it could go to 4.5 inch bell crank, maybe 5. This is set up to 4 to a little over 4. Okay, here's the beauty of this whole thing. Once you lay up this carbon fiber sheet and you pre-preg it on here, the next step, it goes into a water jet cutter. Now, if you have access to the program for the water jet, you can program any size bell crank you want. Now obviously you can't change the hump location. The hump location here is what forms the fork. But you can move the holes out of the way and make the fork a little bit longer to have a different size bell crank. So everything is adjustable through the program of the water jet. So this is where I'm at now. This is I worked on this plate the other day. This is ready to be put the release agent on it, and I'll take it in to JT and they'll pre-preg it for me. Okay, so going forward, this was just a small sample. I'll take you over here. Let's see, this big plate, and I showed them to this at work, and this might be overkill. So here's a plate of 2024 T35. It's not as gummy as 6061. It's a harder metal and it polishes. But I'm not sure the dimension. I could probably get a tape, but anyway, you can tell it's a big plate. Over there, you saw an aluminum plate with another plate sitting on top of it that formed the hump. The idea behind this plate is I don't build up the hump. I machine a groove out between the humps to form the fork. So this whole plate is a plating for bell cranks. I found a CNC service that will actually do 42 inches right here. Their machine will CNC a mill 42 inches, and that's what this plate is, tall by whatever width. So I'll probably have the mill on both sides, but we're only going to lay up one side at a time because it gets complex when you try to put pre-preg on both sides. So that's where I stand here. This thing's got to go into the milling machine and get this milled out. Now the reason why it hasn't been milled out yet, I need to get more samples off of that plate over there. And once I get those samples, I'll put together some bell cranks, and then we'll come up with the ideal layup as far as strength to weight ratio. Here's the mess I got going over here. I've got some wire benders. So this concept is, this goes in a vise. Okay, this is a little test sample here. The way this works is these two plates go in a vise, and when you put them in the vise, as you slide this back and forth, you adjust the width of your horn. So that way you bend a 90-degree, you find out how wide you want your horn arms, you adjust this back and forth till you get what you need, and then you bend the other one so it's repeatable. These were jigs that I made. I'm not sure if I'm still alive. I might have been dropped out. Okay, I think I'm still going. Okay, so these jigs were made with these dowel pins. This is a 1.5, and this is 2-inch. You know, just all different dimensions. Here's the pins. Here's the small pin, and then I got a box of the bigger pins. These are 1/4-inch pins, and these are 3/16 pins. Now, if you get the old K&S bender, let's see. Basically, the K&S bender had, I think, the 1/4-inch right here. Old K&S bender was a 1/4-inch peg here. It's like right there. And then the pin on the handle, that was the 3/16 pin here. So it's real simple. I mean, you just get metal supermarkets, you go in there in the scrap bin, you start making your own benders. So that's a rabbit hole project here. I got to the point where these two pieces, these plates, would go in the vise right here. And if you're familiar with not precision vices, anytime you have two pieces, it'll clamp on one and not the other. One of them will slide and the other one won't. I compensated for that with putting a hard rubber plate so it mushes down and holds these in relationship to each other without sliding. Going forward, I might machine a block like this to where there's a slot here and a bolt where you can actually slide this plate on a block to get your dimension. This here goes back to the wheel pant. One of the problems with the wheel pant before was the Formica. It wasn't very user friendly for a hobbyist because it took a scroll saw to actually cut this out for a jigsaw. What this is, 1/4 inch PVC foam board. So it's got a slick surface on it, but in between the slick surface is it's like a really dense foam, and you can cut it with a hobby knife. Now you're not going to make one slice and get all the way through it. It's going to take a while, but you're going to be able to make multiple passes to get your parting board. And of course you could get anything to make the box out of. This was just 3/4 inch scrap maple, or poplar, I'm sorry. These were the cutouts for pocket cup hinges for a cabinet. So this was a test sample for the depth scrap, and that's how I made the parting board. And the PVC 1/4 inch board is great for stuff this size. There's all the little soldiers. Here's the little soldiers out of the mold. These all have to be deflashed. In between iterations of this stuff, I get off on a tangent and I do high temp stuff with these bell crank molds. And over here, let's see what we have. This stuff here, basically, these are all the gear. This is an RC plane here. That was on a stick airplane. But here's all the different configurations. Some are wider, some are narrow, but this is what they look like when they come out of the mold. And then you got to go through there and clean all this flash up right here. So that's a lot of work. I like doing this and the bell cranks all at once, and that way you're making a mess and you're all set up and you just keep rolling with it. Here's a little contraption that I made. It sort of saves the dust factor. This corrugated metal here was Metal Supermarkets. It's I don't know, 1/16, 1/32 thick. It's they got two versions of this stuff. One of them is stainless steel and the other one is like steel. And what I did is I made a box, okay, that this tacks onto, and then the box has got the port for the vacuum. So you plug your vacuum in here and basically it turns it into a cheap hobby downdraft table. Now let's just say you're working some carbon fiber and you're over this area right here. I just take 8.5 by 11 sheets of paper and lay up, and it sucks down on the plate, and then it allows more vacuum to come through this one spot. So you can vary the amount of vacuum and flow by choking some of this off if you don't need it, if you're just working in one area. If you're sanding a stab or sanding something you know, fairly large, you can actually just leave it all open. And to pull the vacuum, it's just a shop vac. It's a pretty big shop vac, but that's what I hooked to the that little downdraft table. So that's pretty much where I'm at. Just a quick shop tour. I won't go into a lot of stuff where I'm going to build. I'll probably edit it. Today I think I'm going to do some horns, finish up the horns, and then also, let's see the comments. Yeah, I think I missed the comment. It disappeared. I think like Wendy had that. Wendy showed a video. He had a table with downdraft in it. So sort of, I think it's the same concept, but I think it's this one's a little bit more portable. If I had a lot of room, I'd love to have a designated downdraft table. But what I try to do if I'm deflashing a lot of carbon or grinding on it, I take this this workbench here, this bench right here, all these tools right here, the sanders, the grinder. This is the messy bench, and the beauty of the messy bench with all the sanders and stuff, I can take this whole cart. This got drawers built in, but I take all the cart and everything that's on wheels, and I just roll it out in the driveway. And that way, if it's 20-mile-an-hour winds, and put a mask on, and that way you can just grind away. So that's what I use all this stuff for. Everything on this bench is like grind and cut. So I think that's about all I wanted to talk about. Didn't want to stay on here too long, but I'll finish up my projects, and the people I promised stuff to, I'll ship it out to them, and that way they'll get their stuff. If it wasn't for the foot of snow and some car problems in the family and other issues, that I probably wouldn't have been in the situation I'm in now. But it's encouraging going forward with the bell crank stuff. I've got the shoulder bolts and all the different things sourced out. Bob Hunt helped me with that, and he gave me some product numbers he thought would work on this thing. I don't want to actually get that big plate milled until I get the thickness and the design locked in. There might be a few things changed, and I don't know what they'd be, but it's like with this plate here, this is, this is variable, okay? This is the plate that creates the offset in the bell crank. And the beauty of having these plates separate from the call plate is they're variable. You're not stuck with one dimension. Now, once I get that plate milled, that's it. So I wanted to get it locked down with these plates. And, so anyway, that's encouraging. And then the foam wing over there, the concept was Steve Berry and this Genesis 35 project. And it's sort of out there. It's sort of involved, but this was the wing, okay? It's got the leading edge radius cut into it, and I've got a 1/4-inch trailing edge on it. And Joe Daly had a video, and I went back and watched it. And Joe Daly did a version of this where he's trying to duplicate the mold in the wing on his plane he just built. So if you're familiar with these composite airplanes, basically the way they're built is you have a female mold, okay? You put your fiberglass in there, 1/2 ounce, 3/4 ounce, and 1/4 ounce and a half, whatever, somewhere in between. So you put your fiberglass in there, but then you got to put a core material. And the problem with core material, if it's flat, it's easy. But if you have a compound curve or a lot of different curvy shapes, it's hard to get the balsa wood to conform. Now you can do it with a vacuum bag, but it gets complicated. And if you go with balsa wood, you're right back in the same spot you were before with the cost and availability of balsa, and I wanted to eliminate that. So my process was going to be eventually get rid of the balsa wood, but not on this wing. I'll substitute foam. So here's the process. You get this wing, and then you get another one that's a buck. You use one that's maybe 4-pound foam or whatever, it's cut accurate, and you use that to wet form your sheeting, okay? You form the sheeting all the way around the whole wing. And you gotta make sure that the leading edge sheeting actually, when it's wet, will conform. So once you get your sheeting, you pull it off your buck, okay? It's the same process of turtle deck or all these other parts people are forming. You pull your sheeting off the buck. Now obviously, now you got your sheeting like this, you can't wet it out with epoxy because normally you do that when it's laying flat. And this is an experiment. So what I was going to do is take 3/4 ounce glass cloth, half or whatever it might be, and I'll wet it out on a piece of plastic on this workbench. And I'll squeegee all the excess epoxy out of that glass. And I'll take that plastic sheet, like Visqueen or something, monocoat backing or whatever, and I'll apply that to this wing, and I'll transfer the wet fiberglass to the foam core. Then I'll take the molded balsa wood and I'll put over the top. So the glass cloth that's wet out with resin will be the adhesion between the wing, skin, and the foam. And it'll be vacuum bagged down. Okay, there's another tricky thing, and it took me a while to get around it. So you put a spar in here, right, which is straightforward, and then you put landing gear clips. Once you get the landing gear clips in, if you core this out first, you can't vacuum bag it. So here's how I came around that problem, and it's sort of involved. It'll be a vertical balsa spar with carbon fiber cap top and bottom, and then capped again, sanded smooth with balsa. And then I'll make a pattern of the cross section of where the clips go. From that pattern, I'll make a mold, and I'll make a carbon fiber clip, landing gear clip, that fits this way into this foam wing out of carbon fiber. The mold buck I make the clip profile from will be on a wing that's already cored out. So I know exactly if I core it really tight here and a really tight dimension here, when I pull these cut pieces of styrofoam out, it'll tell me exactly how thick that foam is in this area. I'll make a mold of the carbon fiber clips that will go in there. Then I'll vacuum bag it. So it's all a solid wing with a spar and 2 clips that are carbon fiber. When it comes time to core the wing out, I can core right through those carbon fiber clips because there'll be a small profile and it'll match the core perfectly. Now the hump where the gear goes and whatever's got to be figured out, but it doesn't have to be perfect, but it'll be cored out. Okay, so here's the next step of the process. I got a foam wing with all the stuff in it, clips, spar, and it's still solid. I've got glass cloth with balsa wood on it, vacuum bagged down. So then out comes a wing that's got balsa wood on it with glass underneath it. Now it's raw wood. The next step is to take glass cloth cured on a glass plate at a higher temp, maybe up to 200. Get a high temp wet resin, wet it out on glass, and if you post cure it, I'm not positive, but I think you're going to get away with a print through. Once you take that up around 200 or whatever, and you post cure this skin, you're not going to get any print through. So let me go over here and I'll see if I can find that sample. So here's a sample piece. This is glass cloth, wet out on plate glass. So this is HTR 250 1063, I believe. This is 3.2 ounce style 120 glass. This is more like an RC wing, okay? This was just an experiment. So this is your outside wing skin. And as you can see, your outside wing skin is as shiny as the plate glass it was cured on. So if you can imagine this being 1 ounce instead of 3, and what you're going to do is, you remember you got a balsa wing now, right? No core in it, no coring done. And then you're going to take this wing skin and you're going to wet it out with a little bit more epoxy, and you're going to wrap it around this wing. Okay? And then you're going to vacuum bag that down. So basically you've got a wing that's pre-finished. It's already got the gloss, it's got everything it needs. The trick is, if the balsa wood's not perfect, this won't make it perfect. I mean, you got to have it to where it's good. Now, let's just say there's a little sanding. You got to block sand it and dust some primer on it to get rid of some spots. You know, there's no way to get a 20-point finish without block sanding the airplane, in my opinion. I mean, you got to build the finish up, not pull it out of a mold. So anyway, yeah, this goes on the wing, okay? And it's vacuum bagged down, and this is your skin. So in effect, what you've done, you've created a core. You've created glass, foam, glass, wood, and glass. Now here's where the weight savings hopefully pays off. When you actually core this out, you're going to core all the way to that first layer of glass. The only thing you're going to have left in here is the fiberglass, the wood, and more fiberglass. The only white bead foam that's going to be in this wing will be the vertical spar right here and right here. So in effect, you've created a wing that has the same properties of something that came out of a mold by doing this. It allows you to create a wing of any dimension without a mold. You know, you're not stuck with ABC wing or whatever. You know, it's completely variable for all wings. So that's the gist of it. Now, going forward, I've talked to a few people that really would know. They have highly dense foam. Joe Daly's experimented with it. It's like a white foam. I can't remember the name of it. But what I want to do is get rid of all the balsa wood completely. Get rid of all the balsa wood and also try to eliminate as much foam. Now we're eliminating 1 pound foam and replacing it with 4 pound wood in the best case scenario. What I want to do is replace it with a 4 pound foam core. And that way you've got glass here, foam core instead of balsa wood, which would be a 1/16 of an inch thick, and then more glass, which would be here. And then in turn, of course, you get rid of all the white bead foam. So that's my molded type wing without a mold. It's an unorthodox way of doing it. I think what Joe was doing was similar. He left out the step of this last layer of glass on the outside. I got to go back and watch his video. And I got so busy, and basically I wasn't able to watch his videos as quick as he's putting them out. And same with stunt hanger stuff. get bits and pieces, but I took on some work that it's going to pay off, and I like doing. So basically all the things I had going just sort of slid off and got postponed a little bit, but I'm back on it. Now, the best case scenario, I'll go ahead and mention this because heck, they got it on their website or their Facebook. The JT Composites in Indianapolis, they purchased a Thermwood 67 5-axis milling machine, and this thing, it wouldn't fit in this garage. Let me put it that way. It's a big 5-axis milling machine, and the idea behind that concept is it'll do so many things. It'll tool. It's a high-speed CNC router. So this router motor is probably this big, you know, it's big square. It comes down, and it's on a big gantry. Okay, it's on a pillar. It goes up and down. It's on a gantry that goes up and down. I don't know. It's 5-axis, and then the actual motor is on like 2 gimbals. I guess you could explain it like a gimbal, to where the router motor pivots. Okay, it goes, you know, whichever way. And then the table that everything sits on, I think there's 2 tables where you can do 2 parts individually and load one in one machine and whatever. Or you can hook the 2 tables together electronically to where they all move in unison. So you have the table moving, you have the router moving like this. So if you can imagine a whole stunner sitting there in tooling board or some kind of foam, and that router coming down, and it would machine either the male pattern or the female for the mold, you know. This is a type of product they use in a lot of those machines. This is a high density tooling board foam, and I'm trying to just think of a good craft reference, but it's almost like light basswood. You see how easy that shaves? But this is the kind of stuff that holds its shape. It's got a lot of density that they put in one of those machines. So when it comes time to machining tooling board, it's not like metalworking where it's slow. I mean, these routers, I don't know, I'm guessing maybe 20,000 RPM, 28,000. They come down with a big bit. When they start going through foam, I mean, the foam is flying. It's or the tooling board. It's a different, quicker process. So that's encouraging. It's neat. It's sort of like the best of both worlds. You still have the ancient technology of the water levels if you want it, but you know, we have all the technology for the CNC stuff. So we got 6 watchers and some thumbs up. So I'll jump off of here, and I want to thank you for coming by and listening to my spiel and seeing where I'm at. I'll get back in the groove here and get some stuff out to the people that wanted it, and then carry on. Thanks for watching. I'll see you later. Willy Wonka. I hear that. I hear the Willy Wonka.